Hello student, welcome back to your favorite technical channel AVM Tech Android. Today in the video lecture we are going to discuss chapter 2 of basic mechanical engineering, that is property of gas. So this chapter is separated in 7 different videos, and particularly from this chapter numerical will be asked in your internal test. So when we'll talk about this second chapter, numerical, that will be asked, that is of 7 mark, or you can say numerical which contain 2 or 3 marks, and some question related to remembrance level like state the Boyle's law, state the Charles law, state the Gay-Lucas law. That kind of question will be asked. So in the chapter 2, in the first topic, we are going to discuss about different laws. ये लो आप अपने स्कूल डेज में पढ़ चुके हैं. सो क्विकली विल रिवाइज दिस पार्ट and will go for different non-flow processes. So before we'll go for different laws, first we must understand what is the difference between vapor and gas. So when the question is asked in the exam, differentiate between the vapor and gas or any difference, you make two separate columns and you have to write the difference like what is shown here. Okay. So what is the major difference between the vapor and gas? In that we can say that the liquid convert into vapor at a temperature higher than boiling point temperature at a given pressure. So here temperature is higher than boiling point temperature, but in case of gas, the liquid convert into vapor at a temperature higher than its critical point temperature at a given pressure. And we can say that the example that include, you can say steam, that is if we talk about water vapor, that will condense and it will form the water. But if we talk about oxygen, hydrogen, nitrogen, these are the gas, it is at permanent state and in normal temperature and pressure they will not condense. So this is a very important difference between vapor and gas, and we have to discuss about different gas laws, and this entire chapter is related to property of gas only, not vapor. Now we have to discuss about different gas laws which you learn in your school days. That include, you can say first, that is a Boyle's law. So Boyle's law, that is giving the relationship between the pressure and volume. It tells that when any gas is heated at constant temperature, its volume is inversely proportional to pressure. Or you can say at a constant temperature, the pressure of the fixed mass of gas is inversely proportional to volume. So P is inversely proportional to volume, or you can say P1 V1, that is equals to P2 V2 at constant temperature, where P is the pressure of gas and V is the volume of the gas. So this is a PV diagram. Initial state is a 1 where the coordinates are P1 V1. Final state is 2 where the coordinates are P2 V2. And what you will observe here is at the constant temperature, when you can say the pressure is increased, volume will decrease. So what you will observe here is 1 to 2 is the process, and from initial state we will reach to the final state where the coordinate for final state are P2 V2. So according to Boyle's law, if you plot the graph of pressure versus volume, it is a rectangular hyperbola. But when we will plot a graph of pressure versus 1 upon volume, it is a straight line. So this kind of numerical that may carry 1 or 2 mark weightage, that may be asked, that include the application of Boyle's law, that indicate if the gas has a pressure P1 equals to 1 atmospheric pressure, volume V1 equals to 4 liter, and it when the pressure changes from 1 atmosphere to 2 atmosphere, what is the volume final? So that is P1 V1 equals to P2 V2. So initially P1 is a 1 atmosphere, V1 is a 4 liter, P2 is a 2 atmosphere. So 4 into 1 divided by 2. So your final volume at state 2 is a 2 liter. That is as per the Boyle's law. So now we have to talk about Charles' law, that is giving the relationship between temperature and volume. The statement is at constant pressure, the volume of fixed mass of gas is directly proportional to its absolute temperature. So here the temperature is absolute temperature, capital T, and the unit is Kelvin, not degree Celsius. So V is directly proportional to T at constant pressure, or you can say V1 upon T1 equals to V2 upon T2. And same thing is mentioned here with help of this PV diagram and with help of this schematic diagram. Initially you can say the gas is at T1 and V1 state. When heat is supplied, it will reach to the V2 and T2 state. So you can see, if the initial volume is 2 liter, temperature is 300 Kelvin. Now if final temperature is 450 Kelvin, what is the V2 value? So V2, that is equals to V1 into T2 divided by T1. So V1 is 2 liter, 450 is the T2, and initial is 300 Kelvin. So the final volume is 3 liter. So this is a Charles law which is giving the relationship between V and T. In the similar way, the third law is related to this Gay-Lucas law, which again you learn in your school days, that is giving the relationship between P and T. So what this law state? So this kind of question may be asked in the exam. This is related to remembrance level. State the Gay-Lucas law, that is of 1 mark. So at a constant volume, the pressure of a given mass of gas is directly proportional to the absolute temperature. So P is proportional to T at constant volume, or you can say P1 upon T1, that is equals to P2 upon T2. So what you can see here in the system is, this piston is a fix and the heat is supplied. So initially temperature is T1, pressure is P1. When the heat is supplied, what you will observe, there is a rise in the pressure, corresponding to that there is a rise in the temperature. So what you can see or what you can understand by this numerical is, initially pressure P1 is 1 atmosphere and temperature T1 is 300 Kelvin. Now we have to find out what is the P2 pressure when the temperature is 600 Kelvin. So P2, that is equals to P1 into T2 divided by T1. So P1 is 1 atmosphere. This is 600. This is 300 Kelvin. So what you will observe, pressure is also increase with increase in the temperature. This is Gay-Lucas law, what we had discussed. Next is Avogadro's law. So the statement is, at the same temperature and pressure, equal volume of all the gases contain an equal number of molecules. So when the pressure and temperature is constant, V is proportional to N, that is at constant T and P. So V1 upon N1, that is equals to V2 upon N2, where N is the number of moles of gas. So you can see, if 1 mole of gas occupy 22.4 liter is standard temperature and pressure STP condition, then 2 mole will occupy 2 into 22.4, that is 44.8 liter. So that is as per the Avogadro's law, where the pressure and temperature remains same or constant. So now when we combine Boyle's law, Charles' law and Gay-Lucas law, we will get a very important relationship which is helpful throughout the life, that is P1 V1 upon T1, that is equals to P2 V2 upon T2. So that what is use of it? To find out the state of gas when pressure, volume and temperature change simultaneously. Now we have to talk about the next part, that is the gas constant. Again you learned this in your school days. PV equals to nRT, where P is the pressure, V is the volume, N is the number of moles, T is the temperature and R is the universal gas constant. So ये सब चीज़ आप अपने स्कूल लेवल पे पढ़ चुके हो, so it is a not new thing for you. Now the next thing is the relationship between Cp and Cv. So in the chapter number 1 in the previous videos we learn about specific heat part. So Cp and Cv, that is a specific heat at constant volume and at constant pressure. So for 1 mole of ideal gas, Cp minus Cv equals to R. This is a very important relation, and in the exam in 3 mark the question may be there, you prove that Cp minus Cv equals to R, or this relation may be asked in the technical test in the campus interview, Cp minus Cv equals to blank. All that kind of question will be there. So now we have to prove that Cp minus Cv this is equals to R. So now we have to prove that Cp minus Cv equals to R. So what we'll do is, according to the first law of thermodynamics, what we learn in the last chapter, in chapter number 1, Q equals to delta U plus W. So we'll go for dQ, that is equals to du plus pdv. So when we'll talk about the constant volume, dv is equals to 0. So this dv part is 0. So dq, that is heat supplied at constant volume, that is equals to du. It is directly affecting the change in internal energy, or that is equals to Cv into dt, that is specific heat at constant volume into change in the temperature. But now when we'll talk about the constant pressure part, the heat supplied at constant pressure, that is equals to Cp dt, like this Cv dt, that is equals to du plus pdv, that is according to this first law of thermodynamics. And now what we know, that is the ideal gas law, pdv equals to rdt, that is pv equals to mrt, what we know. So what we can see in this equation is Cp dt. So this Cp dt, that is equals to Cv, because this du, that is equals to Cv dt. So we'll put here, that is equals to Cv dt plus this pdv, that is equals to rdt. So this rdt we are putting here. So now what we are doing, we are cancelling dt from all the side. It is common at both the side. So what we will get, Cp, that is equals to Cv plus R, or you can say Cp minus Cv equals to R. That is a proof. So we can say that specific heat at constant pressure minus specific heat at constant volume, that is equals to R, that is a gas constant. Now the ratio of specific heat Cp by Cv is called adiabatic index gamma, and gamma value for monoatomic gas is 1.67, for diatomic gas it is 1.4, generally it is for air, which we have to remember, and for triatomic gas it is 1.33. So this gamma value, that is you can say adiabatic index value, that will decrease from monoatomic gas to triatomic gas. So 1.67 to 1.4 to 1.33. So this slide is a summary of what we did or what you learned till this point. That is, you can say Boyle's law. The relation P is proportional to 1 upon V at constant temperature T. So equation is P1 V1 equals to P2 V2. Second, you can say it is a Charles law. It is giving volume that is proportional to temperature when the pressure is constant. So V1 upon T1 equals to V2 upon T2. Gay-Lucas law, that is telling about P is proportional to T when volume is constant, and we'll get P1 upon T1 equals to P2 upon T2. If we'll talk about Avogadro's law, then again what we will see, V is proportional to N at constant pressure and temperature. So V1 upon N1 equals to V2 upon N2, and when we'll combine all these first three, we will get P1 V1 upon T1 equals to P2 V2 upon T2. The ideal gas equation, that is PV equals to nRT, and the relationship between Cp and Cv is Cp minus Cv equals to R. Now other two important laws which we must know, that is Joule's law in the thermodynamics. So according to this Joule's law, according to the Joule's experiment, the internal energy of ideal gas is a function of temperature, or it is directly depend upon its temperature, not on the pressure and volume. So internal energy U is the function of temperature only. Hence this internal energy U of ideal gas is only depend upon temperature. This Joule's experiment we discuss in the first chapter, and again we will discuss in the engineering thermodynamics subject. And the last one is the Dalton's law of partial pressure. The statement is, when two or more non-reacting gases are enclosed in a vessel, the total pressure exerted by the gaseous mixture is equals to the sum of partial pressure of individual gases. That is, the total pressure exerted equals to pressure of gas 1 plus pressure of gas 2 plus pressure of gas 3 plus so on, where P total, that is the total pressure of gas mixture, whereas P1, P2, P3 are the partial pressure of individual gas. The meaning of partial pressure is known to you, even though for more clarity it is mentioned here. If you want, you can go through it, and hence all the important gas laws are discussed which you learn at your school level. आपने ये सब गैस लो अपने स्कूल लेवल पे पढ़े ही है, फिर से हमने वो रिपीट कर दिए ताकि व्हेन विल गो फॉर नेक्स्ट वीडियो आपको सब पता हो कि कौन सा गैस लो कहाँ पे एप्लीकेबल है, उसका इम्पोर्टेंस क्या है. सो we'll meet again in the second video lecture for chapter number 2. Meanwhile, do not forget to subscribe this channel, like this video, and share this channel, as well as share these videos to your friends which are belongs to different institute across the state or across the country. Thank you very much.